Hello everyone, my name is David Hock from Infosim, and in this short video here for roughly 10 minutes I want to give you an overview of the AI-Net Protect final demo use case that we have prepared together with some other partners, Infosim, Waystream, Fraunhofer HHI and Consistec. And this demo is part of a large CELTIC-NEXT project, AI-Net Protect, that runs since 2020 and will end mid of 2024. We specifically want to look at, in this demo use case, into comparing SNMP and telemetry and a measurement setup, how this can be done, and provide also some examples of a comparison. Let me first quickly motivate this. SNMP is a widely supported and standardized protocol that has been there for a few decades already. And SNMP is probably the most popular protocol being used for network monitoring in large infrastructure performance management solutions, and it's working on a pull-based system, so the data is being pulled by a manager, as you can see here on the picture, and the device is then answering with the data. Typical frequencies are 5 to 30 minutes, can be run more often in some cases, but typically this is not being done for scalability reasons and for large networks. And this is also where telemetry comes into play, because whenever you are pulling these devices need to know their state, answer the SNMP request, which causes additional load on the device. And the more often you ask, the more often this is being happening. In telemetry, the approach is being shifted. A collector is just subscribing once to the information, and then the device is just constantly pushing the most recent information. This can be done even like in a second scale or 10-second scale, so far more often than typical for SNMP. And the device does not need to handle a lot of states, but it's just directly pushing out the data. This is the idea of this. The practice shows that this is recently has just come up recently in the last few years, that this is really getting to more and more places actively in the network, and there's still a learning curve. So we can see that people still try to implement this in the best possible way, and there is also at least a potential, not to say a risk, for excessive bandwidth and storage use if you are pushing a lot of the data. So for this purpose in this project, we have been looking at the two different approaches and wanted also to create a framework how to compare both of these approaches. Let us quickly look at the final demo architecture. This is the overall demo architecture that we have built together with a lot of different partners in the AI-Net Protect project. Not all of these components are relevant specifically for our use case. In our use case, we are specifically focusing on this part here. Our measurement setup contains of the optical access switches, in particular one selected Waystream switch we will show our use case with. We are using different protocols, CLI for configuring and reconfiguring the switch and the telemetry frequency. Telemetry we are using for actually getting the data from the switch push-based, and SNMP obviously we are using to pulling the data from the device. The polling itself and also the reading of the telemetry and the interpretation of the telemetry data is being done with the network management system StableNet by Infosim, where we have used this project to look into how such a project could potentially be extended to read such data, and have created proof of concepts, which we are showing here. Consistec as well from is our partners participating with Kaplan and extensions to that, proof of concept extensions, where we are actually looking into the traffic, and also Fraunhofer HHI is helping here with the telemetry framework. So now last slide before jumping onto the live demo. Just for the measurement procedure and the setup we are using, we are looking at this one selected example device here for the live demo. The device has several active interfaces, one loopback and 5 external interfaces that we are measuring both with SNMP and telemetry. We are measuring different parameters. In particular, we are measuring the in and out octets, so the incoming and outgoing traffic of the interface. We are also measuring SFP and environment information using telemetry, and system load information using SNMP. And in order to show a little bit the different effects on the load in the network and the load on the devices based on different measurement intervals, we are over time periodically changing the measurement frequency. So we are not like running SNMP all the time every 5 minutes and telemetry every, let's say, 10 seconds, but we are switching this. Sometimes SNMP is running every 5 minutes, then every minute, and then every 10 seconds. And for telemetry as well. One thing to point out here is that in each time of the setup of the measurement run, the telemetry data are measured at least as frequent as SNMP. So the value here in the lower row is always lower than in the higher row. Now let's look into the system. First, opening a web-based dashboard here, where we have compiled a summary of the information from our measurement setup. You can see here a dashboard from the network management system with the different partners involved and again the project setup. And here now we are getting live data from the setup running at Fraunhofer HHI. And maybe just to pick some examples here for the sake of the demonstration. First of all, we have here included a picture of one of these Waystream switches, as we have one in the lab. This picture has been enhanced in the weather map here with icons that are actively indicating whether the port is up or down and whether there is measurement data. So this is not just a still picture, but this is, as you can see here, this is while I'm recording this video, this is live information. And we can actually see here that green indicates that the port is up and there is measurement data coming. We also see ping statistics to that device, so you can see that our SNMP, our network management agent, is very, very close to this device. There is not a large delay. Now we have 5 interfaces that are on state up, Ethernet 01, 02, 03, 04, and 124. And the first data we are seeing here that's being obtained by the network management system is actually the total traffic in the last 24 hours. And we can actually see that there are just 2 out of these 4 interfaces where there is a lot of traffic flowing. This is the interface 01 and 02. And you can see that measuring both different approaches, the total traffic is equal, which should also be the case because you shouldn't miss the data when using the other technology. You might just miss some of the high peaks, but the overall data that is transmitted with the counters is the same for both technologies. Now here we have we look at the measurement run with the varying monitoring frequency. So I had shown you in the table that we are changing the frequency of measurements, and to that end we have first control measurement that is actually measuring how many actual measurement points per minute we have for both technologies, blue being SNMP and red telemetry. And you can see here that whenever we have 6 measurement points per minute, this means we are measuring every 10 seconds. When we have 1 measurement point per minute, we have a measurement every minute. And when we have only 0.16 measurements per minute, then this is every 5 minutes. No, 0.2, then this is every 5 minutes. And this actually indicates that here you can see for SNMP and for telemetry this is changing. And as you can see from the red curve, for telemetry more often we are measuring in a higher frequency. Now let's look at the actual measurement values. Here you can see the average curve, which is here the solid line in the middle, is roughly the same for both technologies, SNMP and telemetry. Obviously, because the measurement points are not exactly at the same time, there are small differences also according to floating and rounding, but the average is generally very close to each other. Whereas when you are looking at the maximum and the minimum values that have been seen in a given interval, you will see some differences. And this you can actually see by the shadowed area here. So for every measurement point, we are showing a solid line, which is indicating the average in this time. And the lower part of the shadow is the minimum that has been seen in this time by the measurement, and the upper end of the shadow is indicating the maximum that has been seen. And as you can see here, whenever we increase the granularity, we get a larger shadow area because we are seeing more of the outliers to min and max, whereas when we are measuring less, we have a smaller area up to the case where both measurements are just running every 5 minutes. So in this case, you can see this here, the measurements are just just run every 5 minutes. And in this case, the green shadow area is non-existent because there is only one value aggregated per 5 minutes, and there is only one value. Now let's look at the overhead. So we are now looking at the actual traffic using Kaplan from Consistec. We are looking at the flows. We are looking how much traffic is actually being created by the different protocols. And to that end, we are comparing the SNMP traffic on the one side based on UDP port 161, and on the other side, the telemetry traffic coming TCP based. That we can identify due to the help of our partner. And if we look at this here, we can actually see that obviously the more often you measure, the higher this has an impact on the traffic. We can see here nicely these steps. What we can also see is that generally looking just at the few interfaces and this one device that we are testing here as an example, we are in the range of kilobits or tens of kilobits. So this is not really impacting the system at all. But still, this might have to be taken into account if we are running on much larger platforms with a lot of different devices. Then at some point, this might add up. If all 24 interfaces are up and all 24 interfaces are being measured, we already have 4 times this. And if we have 1,000 devices, let's say 10,000 of devices, then this suddenly might add up to limits where this is getting relevant. So here we can see the traffic, as I said. We can also see that in general, the SNMP traffic is less than the telemetry traffic. And for the CPU, we are not like here able to differ specifically between the CPU usage spent for SNMP requests and the CPU usage spent for telemetry. But we can see in general then whenever there is a higher traffic load, so there are more telemetry packages sent, this also has a slight influence on the CPU of the device. Again, we can see that this is not a large impact, but it is something that might have to be taken into account in general when looking into larger setups with a lot of different devices. Now to end this presentation, just with the intent of this presentation is to give an overview of this measurement setup. We also have here more detailed statistics with a lot of tabled values where you can more precisely compare the peak values, minimum peak, maximum peak. You can dive deeper into the specific interfaces and see the differences. Again, here you can see the patterns when the measurement intervals are being reconfigured. Then the more often you measure, the more you see actually these ranges, whereas the more rarely you measure, you only get solid lines. And last but not least, I also want to quickly jump to StableNet itself, to the network management system, sort of the backend where the data is coming from. Here we see in a weather map the device again with the pictures. In this case, you can see that those elements are real elements linked to a specific element, and we really have these indicators that are actually referencing to this to this element. You can again see also some statistics with different averaging periods. And if we are looking at the actual setup, here we have the full setup of the final demo. So there are also a lot of components which are not part of this specific demo, but we can also see in particular this Waystream switch here that we have selected. And maybe as the last thing for this particular video here, just showing the device information of this switch that we have been using as an example. So this is a this WYS SW90G, and here we are, as you can see, we have different information about this switch, and also the health status is telling us that we are actually looking at, as I had on the table before, the SFPs, the interfaces itself, some sensors as well, temperatures as fans. And with this, I'm closing the video, jumping back to the original slides. So we have a measurement setup in the Fraunhofer HHI environment where we are comparing these measurements. We are comparing SNMP and telemetry as 2 different approaches for network monitoring, where telemetry is becoming more and more popular. SNMP being the classically supported and standardized protocol. And with our setup, it is possible now to compare different setups, also larger setups in the future, and to get a better understanding in terms of scalability and limitations of the both approaches. Thank you very much.